Hello guys. Maybe I want to talk about homework 7, some questions from our textbook. If you remember, here is the textbook question 5.1, 5.2, and 5.7. Yeah, and yeah. Let but before we start a question, maybe I want to take a quick review of the different kinds of protocols. So MSI and MESI, these two are the two we want to focus on. But actually, in the final exam, we will not cover the MESI. We will only focus on the MSI. Uh, but most of you still may feel confused about how it works. So I'm not sure which picture you will prefer, but we will provide this graph in the exam, this flowchart anyway. So how it works, or when will we need to write back or uh, share the data? So one of the important part is MSI do not answer. I would say uh, answer what read means in the share state. This is really important. You can see it from this example, how it works, right? So, firstly, everyone is empty initially. So when P1 want to read it, it has to get the data from the memory, right? And P3 also empty, get it from the memory. So here you will see why I'm not getting it from P1, why I get it from memory. That is because the MSI design. MSI will not answer the read miss. Here is a bus read, right? Here is a read miss, right? The read miss will get the data from memory, or a modified state. We'll talk about this modified state later, but firstly, you know it would not get the data from a shared state, not shared state, okay? And definitely not from a invalid state. Yeah. So here is really important. And then we'll talk about the modify. So why we will get or how we will get the data from the modified state. Maybe yeah, we can see it from the third instructions actions. So like P3 want to write, did it has X? Yes, it has. So it will change from a share into a modify. And also send invalid. I will say IMV, okay? Send invalid. So the bus will be a read X. It will say I will read something and also have a 10. I want to modify it. So I will also so I just modify it. And also it actually is a write hit. Write hit. And next for the fourth, the P1 want to read it. But since it is a modified state, so what we need to do, you see, we are inside a modified state, but someone want to read, so we need to write back. We will write back and become a shared state. Follow this line. Change from here is change from M into S. And also here you read something, you will be a S. The share means there may be S, maybe one or more copy align with memory, right? One or more copy. I mean, one or more processor. You can say processor, right? But I would say copy. So back to here, we are changing the modified state into a shared state, and also we will need to write back. Right? For example, I am writing like a equal to 2. But initially, a is equal to 1. So I need to write back. And then I will share this a. So how it works? You can split it into two process. So like firstly, maybe I see. I can have a better performance like P1 and P3. P1 initially is invalid, so actually you can say it's a nothing. But P3, I have something in the modified state, like say a equal to 2. But memory will say I will have a equal to 1 because I did not update it. So when we want P1 read X, okay, it's X. So firstly, there is a bus, right? The bus. I will get what? The bus will say, okay, bus, I want to read. And then what happened next? I will capture that, oh, someone is modifying. So first is bus read. And second, the modify need to pass the value, go back to the memory, and also answer your bus read. So I would say second is a write back the new value, right? And the third, you will answer to bus read. So yeah, that is how it works. You will split the modify state into some other states just by nearly 3 stage. So right, and also don't forget that when we start and modify something, you will need to send invalid. Send invalid. That also is the same on the bus, telling others, oh, you should stop. I will have the only copy of the something we want to modify. We want to keep something only modified by myself, only owned by myself, right? So this is actually how the MSI works. Yeah. So when will we write back? Right? We'll only write back on either M change it to S or M change to I. All right, where we have now. Oh yes, where will we need to write back? Just change the modified state into a share or a modify into a invalid. Just these two we need to write back, right? Just these two we need to write back. So yeah, I think here is all for the MSI. And we can create a new page after this. Yeah, let me copy this question here. Oops. The question is right here, but something we shouldn't miss, right? Let me see. So yeah, I will split it. You can see it's a direct map. So that means the address will reflect or project to each kind of lines, cache lines. And there are 4 lines. That is what you can see from the picture. And we should also learn that the text holding 2 bytes each line. So that means for like here is a line. Here is an example. Here is a line. There is a 2 word 1 and word 2. Okay. Actually, for example, this 0010, right? the word 1 is 0, 0, the another is 1, 0. And the address, how the address means. For example, AC, let's say 10. How does AC 10? If you remember, we will turn it into a what? Bit representation, right? A, it means 9, right? If we are using 10. And C is 11. 1 is 1, 0 is 0. And also you can change it into a, right, 1, here is 9. Here is, right, and here is out of a byte. Yeah. So I want to say, what is the address means, right? The address. How can we know the address to affect to which line, right? So actually, you can know that since there are 4 lines and there are 2 bits, so actually we will need 8 bytes of informations as an offset, and yeah, and that will contribute to 3 bits. And also, as we have 4 lines will be 2 bits, right? So the last three, I will say these 3 guys will be the offset, and the 4th and 5 here will be the, you can say it's a index of line, right? So from here, 1, 0 means the second line, right? Number 2, the tag is 2, and we can check that, right? Yes, actually it's in the line number 2. That is how this works, right? So if we have AC 30, actually you would just look at this 30. I will say 30. So the previous A bit will be the same, but the 3's 0, 0, 1, 0, 1, 1, and the 0, 0, 0, 0. You can also see that which line it should be. It should also be line number 2. So AC30 will share the line when you're doing some calculations. And this is what this direct map means, how it works, right? Okay. So are there anything else we may need to learn? I think that's some information from the questions. So let's go for the question 1. So question one, it says, okay, so first we want C0 to read AC20. So do we have AC20 here? AC20. Yes, we have it, but we are in a share state. Remember, we not answer in share, so we cannot get it. We cannot get it from the core 3. We can only get it from memory. We can get it from memory. Okay, we'll get it. And if we want to calculate the address or the line, 20 is actually 0010 and 0000. The 4th and 5th bit will be the line, and that is line number 0. And if you can see some trends, right? It is setting in the cache line 0. So AC20 will be go to the line 0. That works for all these questions. It doesn't matter too much, but you should know that you should get from memory. So what it changed, it just changed the line 0. You can say C0, L0 into a share state, right? Because both C0 and the C3 has the AC20 in a share state, and we have the AC with AC20 with the data is 0020. Actually, it should be a 0020. It's just showing the last two, the last word instead of two words. All right. So here is the first one you need to know. And also, there is a return, right? Because you get it from memory. The memory will return something. And the 0020 is the data returned from the memory. That is the return. And the second, is C0 want to do what? Want to write a C20, the number is 80. Actually, it will be 0080. Sorry, I modify it into 48. Okay, so as you know, we are saying here, right? Do not depend on one another. So after every part of the question, you will initial the whole state again, right? So see the part B do not depend on part A, okay? So that again, we do not have the AC20. We will need to, actually we don't need to get it from the memory because we will write it. We will do what? We firstly send invalid to tell others don't, to tell others they means nothing. And then we will do the, actually it will be the bus read X, right? And then we will do our modify. We will change what? Change actually nothing into a modify. So we can check. Anything change? Yes. C0, L0. We now are modifying AC20 with the data is 0048. And also we want the C3, right? C3 line 0, it will be invalid because I am sending invalid. It means nothing. I am modifying it, although you have something inside, but I will be the latest one. I will be the update one. So you means nothing. AC the C3. Okay. So let's go for the part 3. That is C3. We want to write AC20 into a number of 80. So do we have it? Yes, we have it, right? We have it. So it's a write hit. It's a write hit. So I will also want to, right, send invalid. And also I will change our state into a modify. Since there are no one has the AC20 else other than our C3, so nobody need to be invalid. We just change ourselves C3 line 0 into a modify AC20 with the data 0080, right? And the 4, you want C1 to read AC10. C1, do we have AC10? We don't have, so it's a read miss. And did any others have AC10? Yes, we have it. We have it from the C0 line 2. So firstly, what we need, the C0 line 2 need write back, right? Remember, I'm modifying it, so I need to update it to the memory in order to answer somebody. So actually, the first stage will be the C1 send bus read X, and then the C0 answer. C0 need to answer actually just firstly write back, and then 3 C0 line 2 will pass, or actually answer 0030 to the C1 L2, right? So who was changing? Firstly, the memory has been changed. Our AC10 have a new value that is 0030, and then the C0 and C1 line 2, they are both in a shared state with the same address, with the same data. That is how the C1 updated, C0 updated the data as a modified state. And 5, it will be C0 want to write something into AC08. The value is 78. Actually, it's 0078. So let's see. Did we have AC 08 in a C0? Yes. So it's a right hit. So firstly, send invalid, or you can say it's a bus relax, and then I will change myself S to M. So for the first stage, I will mean, did any others have the AC 0A? Yes, we have. The C3, right? C3 line 1 have the AC 08. It will be invalid, right? You means nothing. I will be the new. Although you'll have something inside, but I'm the new. Who am I? I'm the C0 line 1. I will be in a modified state with the updated data, or you can say it's a dirty data. So this is how this things analyzes for 5.1. Okay, and then we'll go to the question 5.2. It will say it says 2 different kinds of implementations, but what's the most different is about the stores or clock cycle you take from the cage. I mean, answer from the cage. And another thing I want to emphasize is that the write back block, it says when it's on an exclusive, I mean, it's a modified state, you need to write back, right? Okay, so there is a conflict or modify. Yeah, just as what we said, modify change to I or modify change to S. You need to write back. And the read and write hit will have no stores. Hits have no stores. The misses will generate the stores when you satisfy from the memory. As we remember, the MSI, you can get it from memory or get it from a modified state, or you can say it's get it from the cage, right? So, and also the write hit will generate an invalid. So write miss will not have an invalid, right? There is how it defines definitions, how it says. So yeah, just read the questions, okay? And there is or may happen, right? Okay, and then let's go back to our questions. What our question is, let's say the first set of instructions or actions, C0 read AC20, C0 read AC28, C0 read AC30. Okay, so let's see what will happen. Do we have AC20, right? We don't have it. Right? And although C3 has it, but we will only remember MSI. We get it from memory or a modified state. So you have to get it from memory, right? Because the C3 is not in a modified state. It's in a shared state. You get it from memory. So get from memory will take us about, here we says every two takes 100 cycles. So that's for the first action. And then we see from read AC to 8. The result after the first action will be the C0, L0. It will be a S state with the address AC20 and the data 0020, right? It will go here. And the second, AC28. Do anyone have AC28? I don't think so. Oh, yes, we get it from the C1 line 1. So we can say it's from C1 line 1. So there is a difference, right? We will get it from 40 or 130 based on these two different kinds of implementations. And remember, we need to write back that it takes 10 for both two. So it will give us 50 or 140 for these two. So what's the result? The result is, it will give the result here. They will share the data, right? So yeah, the C0 L1 will have the share state with address AC28 and data 0068. Remember, write back, because we are changing the C1 L1 also in a share. Originally, it's an M, right? M changed to share. It also have the same address and same data. And also, since it's a write back, so if we are doing the same thing as question 1, 5.1, the memory will get memory AC28 will get the new data 0068. This is the write back. Okay, so and then we have the third action, AC30. Do we have AC30, anyone? So nobody have it. Nobody have it, we will say it will get it from the memory. So as we calculated before, AC30 we share the same line 2 with the AC10. So the AC10, what happened in AC10? AC10 is in a modified state. It's in a modified state, and then we want to change it into a shared state. What we need a write back. We need a write back. So firstly, we'll get it from memory. It's take 100, and then the write back that is another 10. That is totally 110. So what will change? Anyone will change? That is, first you will see the memory with the AC10. We get the new data into a 0030, and also the C1L2 will be a want to read the AC30. That is, the data is 0030, right? This is what these three actions. So totally, what we will have 100 plus what? Plus 50 or 140 and plus 110. So totally it will be 260 or 350, right? Based on two different implementations. Okay, and then we may want to go to the next action set. The next action we will say C0 want to read a C00 and C0 want to write a C08 with data 0048, and C0 want to write a C40 with data 78, actually 78, right? So what happens here? What happens? So let's see. Do we have AZ00? No. So any others have it? Also no, right? So we have to get it from memory. Get it from memory, that takes us 100, and what's the result is C0 line 0 with the share state with the AC00. The data is 0010, as same as the memory. And then we will say want to write AC08. So firstly, do we have AC08? Yes. So it's a write hit. So remember what the write hit will generate, right? The write hit generate invalid and invalid. So n invalid is 15. Okay, so we will have n invalid, that is 15 for each of us. So any others have the n invalid? Yes. So the result is, firstly, the C3 line 1, the AC08 here means nothing. It's been forbidden. It's been invalid. And then also the C0 line 1, you can now modify it with the new data 0048. Okay, so there is. And then the third, I want to write AC40. Although there is no not showing AC40 in the memory, but I would you should know that we have it, right? Because none of the other processors, none of the other cores have it. So I will get it. So it's a write miss. Remember, only write hit will have the n invalid. So write miss do not have the write invalid. So firstly, it will satisfy from the memory, and then anything I want to say, that is AC40, right? 40 is 0, 1, 0, and 0, 0, 0, 0. So you can choose the 4 and 5. That's actually the line 0. The line 0, okay, that's fine. The line 0 originally is nothing. Oh, no, it has something. Right? It has the AC 00. It has, but since since it's in a shared state change to a modified state, no need to write back, so it's fine. And also, it was satisfied from the memory, since none of others have the AC40, right? So it's satisfied from the memory and no write back, so it also takes 100, right? So totally what we have, 150, 100, totally 215, right? That's the same for both two implementations. Okay. Okay. Okay, let's go to the third set of instructions. We say C3 want to write something, AC20 with data 0068, 68, and C3 want to read AC10 with, just read it. And C0 want to write AC18 with new data 0070. So what will happen? C3, do we have AC20? Yes, we have. So it's a write hit. It will send invalid. That takes us the NIMV, right? 15. And then another is you want to read AC10. Do we have AC10? No, I don't have it. Any other of us are modifying it? Yes, the C1. So firstly, it will be a read miss, and then the C0 line 2 need to write back, and also answer the C3 remiss, right? The bus read. So as remember, the write back takes 10, the answer takes 40 or 130, so it will be 15, 50 or 140. So for the final, the C0 want to write AC18. Do we have AC18? No, because it's an invalid state. It means nothing. So any of us have AC18. You may find that the core one has the AC18, but it's in a shared state. Shared states do not answer us. So we have to, oops. Oh, okay, am I back? Okay, I'm back. So it's a right miss. It's a right miss, and we need to, although we need to send invalid, but the n invalid is just will happen for right hit, and we are right miss now, so we do not have the n invalid. We do not have it. So okay, so we will get it from memory. Also from memory, that takes us 100. So that is what it is. So totally we will have like 165 or 255, right? That is the question 5.2.